Good morning again. Well, if there were both panels, probably had more people than the audience. I'm happy to be here today and talk about talents and genius education. In the international system, 1990 was a really important date because there was a meeting in Jomtien, Thailand, in which the education ministers of the world agreed to education for all. It was a noble and wonderful goal. 10 years later, in Dakar, the education ministers met again. I was senior advisor to that meeting. And if Ivo has to have a chapter on his failures, I have to have a separate chapter just on that meeting. Because I was arguing with the ministers of education the pledge for education for all. We at that time assessed that there were 827 million illiterate adults. We knew that from careful research that the single most important family improvement you can make is the literacy of mothers. Translates in the economy, into the health of the child, into political participation and so forth. So adult education is terribly important beyond all the other kinds of education. But the ministers of education wanted to shrink their goal to universal basic education, which they did, and that became part of the Millennium Development Goals. It's the only goal, as you know, which is a universal goal, that is a global goal. For all people in an age gender group. So that was fine. But then when Ban Ki-moon came in, another chapter of failures, I was saying, well, couldn't we really now raise the stakes? Couldn't we say for many parts of the world, Latin America, for example, it would be reasonable to say universal secondary education, and for more developed parts of the world, universal higher education, vocational and academic. Can't we really keep raising the bar as we have in so many other areas of our international standards over time? But in a sense now, with the internet and distance education, we're kind of leapfrogging the possibilities. If you add that to the initiative of our fellow Ismail Sergeldin at the Library in Alexandria, along with the Library of Congress in the U.S. and the National Libraries of France and China, to digitalize in another 3 decades or so all the remaining printed information in the world that hasn't been digitalized already, then this internet becomes enormous, and universities are now piling into distance education and higher education. We don't know whether such education is going to produce the well-rounded scholars of the future. I do think, though, that there are certain threats from this vast and wonderful expansion of educational opportunities. If I were thinking of Walter's notion of moving out of reality, if I were the Minister of Culture of France, I might go to the Prime Minister and say, well, you know, we've had a long time goal of helping the world by learning our culture, and for $1 billion a year, I can assemble the 500 magnificent professors, telegenic, wonderful, and I can have the covering costs for free higher education all over the world. And that would be a major, we would get the market. Well, now, that would be a wonderful plus, but the question then is, what remains of higher education in the world if you have a price undercutting on that basis? And if you don't have paying students, how does the research and development part of universities get financed? So there are some serious issues as well as serious opportunities in 21st century education, particularly as it relates, as our topic does, to the genius education, to the talented education, to the people we really want to lead science, technology, and societies of the future. Big challenges. Well, fortunately, we have this plethora of panelists to answer these questions. We're going to try to limit our presentations enough so that we can have a few rounds of questions back and forth. I would welcome that. And then, no matter where we are, the last 10 or more minutes of the panel, we will hear from Emma, and we will look forward to that very much. That is sacred time. We don't impose on that time. So, Jan Dobrovsky, please, sir, you had the first on education for better quality of life.
Fellow Chairman, ladies and gentlemen, I do hope that all of us would like to agree that the key of success is integration. More efficient integration in terms of interdisciplinary cooperation of experts, as well as integration among experts and knowledge-based society. But we have to focus our joint mission for better quality of life for all. It is a problem that everybody should have a chance to take active creative part. And only integration, I think, of our expectation especially of young generation, for the future, better future of course, and some kinds of knowledge and skills could help us. And I do hope that some real activity, long-term activity, especially voluntary training, may be useful for common mission for the future. Let me also refer to my recommendation, I think at the first audio-video conference of our academy, where I proposed, let us learn more from the literature. Let us try to introduce the homeostasis mechanism for more efficient primary prevention of invisible side effects to ecosystem, to whole biosphere, as well as to human beings, to each of us. It is a problem of more efficient primary prevention of environmental health hazard. Let me refer to terrible, let's say, history of incurable disease of civilization like Minamata, congenital malformation of brain. It is hard to imagine such situation, but there were many victims. And still, it is a result of, let's say, of some kinds of, psychological barriers, not technical, because it was good enough, clean technology. And there was some economical motivation. So still we have to learn from the future. We have to integrate, much more efficient integrate, I hope, past, present, and future experiences, especially, good practice, useful for dissemination, for problem-solving training. I introduced this concept of problem-solving training instead of transformative training. It's roughly speaking 45 years ago. And we have some good practice, focus on integration of, some kinds of interdisciplinary case study related to the biosphere, social sphere, and technosphere. So we have inspiration from the nature. And we have also good practice from international school, as I told, voluntary training, workshops in different regions in various countries, not only in Poland. Also in Italy, for example, Spain and some others. And also very interesting studies in France. We would like just to focus, as I told, on protection of homeostasis, both at personal level as the level of the whole biosphere. And we would like to, let's say, to make some linkage between local action, because only local action could be efficient, integration of all partners, like experts from complementary fields, social sciences, economic, natural sciences, practical subjects, eco-innovation, of course. And also, we would like to introduce, for example, biocatalysis, because biocatalysis is very good both for more efficient protection of the natural environment, as well as it is reasonable from sustainability point of view. It is a sustainable economy. We could save a lot of energy using biotechnology, and especially the biocatalytic process for wastewater treatment plant, waste management, and the production of bioenergy from waste, etc. And we have to focus also on innovative study for as early as possible detection of risk factors for human health, including future generation, like mutagens, carcinogens, congenital malformation, also for protection of nature and culture heritage. And we have a good experiences from different countries, from ICTP, Greco, but also Florence and some others. And we would like to disseminate by internet good practice. And let me only focus on the basic ideas as we are very limited in time. And we would like to supplement this problem-solving training and integration of different generations, and also integration of activity of experts and knowledge-based society. We have good experiences in open universities, well, since more than 24 years, focused on the Brundtland report, Our Common Future. It was a starting point. And, it's some good practice in Greek network. Maybe I think useful for the future. And e-learning in cooperation with NGOs. We have a lot of student scientific lab and different innovative technology. I'm not going into details, including laser biotechnology and comparative study. Comparative study, for example, in the oldest in Europe, Border Park in the Kenyan Mountains, founded by the former rector of our university, founder of concept of sustainable management of natural resources, or sustainable development, Lady Professor Gretem, and Florence, protection of the world's culture heritage. I am sure also that the concept of bios introduced by our lady fellow Vladiana Zavanitis is also very, very useful for this kind of mission. And here you have some examples of application of different kinds of innovative methods for early detection risk factors and more efficient prevention and promotion sustainable development of different regions. Very famous because of nature value, like national parks, and culture heritage, like Alma Mater Studiorum Bologna University, and in Champagne in South France and some other region. We also organize several conferences focused on sustainable development and eco-innovation. And the last one was in cooperation with Executive Board of our Academy. We very appreciate this contribution. And you are very welcome to our summer school in this lovely area in the oldest in Europe international park, the Kenyan Mountains. We have just a nice view in September this year. And we would like to refer to this, let's say, starting point of cooperation with the academy. You have a picture from our international 14th International Conference on Sustainable Development and Eco-Innovation. And this conference was also attended by, I think, main expert of the United Nations so far, Clean Energy Concern, Professor Groh. Thank you very much.
Wow. That was a fast run. Thank you very much. Morley?
All right. Well, we'll begin with the title, since it's up on the screen. I want to point out not so much the title, but how much we're all trapped by the culture of Microsoft and PowerPoint. And so, what do we pay attention to when we're with each other like this? Only each other over coffee. But in a conventional way, there's nobody home. We're kind of directors to read something up there as if the words are important. Well, I want to challenge what the meaning is of some of these words and have some fun. Because not very much gets done in a grim kind of mood. And Emo is quite the marvelous mood transformer into fun. Okay. Education at the edge of a paradigm. What we mean by this is educating at the edge of the paradigm. And I suppose we could go in and discuss what is a paradigm anyway, but it's a shift in a global point of view, by and large. And we've been dealing with physics, economics, and kind of a split between the human and natural sciences. So, okay. Points of view. I'm going to steal a little image from Umberto Maturana, who says everything said is said by an observer. Therefore, I want to tell you what kind of an observer I am. Not because there's anything special, but just to point out that it's got a unique background. Well, then over here, let's have this observer number 2. Why? Well, we seem to have a lot of economists here. Now, how many of you are economists? How many of you pretend to be economists and don't want to? What other fields are represented? Do we have any sociologists? Yay! Do we have engineers? Do we have philosophers?
Yeah.
Do we have any? We have a lot of variety here, but it would be kind of fun to find out what the whole distribution is. Okay, now that's who we are. Now, what are we dealing with here? We're dealing with, well, the topic of this forum, which is science and technology. All right, what's the secret? Okay. So I want to give you a little personal history, establish the interest in the subject, and what I'm doing is giving you a report from the past, from a developing country. So whatever your pictures are of Canada now, please put them to one side, because it was not like that not that long ago. And it's not like that now anyhow. But my introduction to the situation in Canada was a report by the Science Council of Canada called Innovation in a Cold Country. Or innovation in a cold climate, I should say. And I will speak more about climate. And I think climate is extremely important, but I mean social climate. Because I taught my original degree in physics, and there were 3 at the university in my class. Just 3. And there was no action in Canada, I thought. That was the image, the culture. So I left and went to the States and then to England, and only came back some time later. So the sense of action, how do you quantify that? I suppose by looking at the patterns of migration one way or another. We have a lot of Americans in Canada who didn't like the political situation there. We can't measure that very easily. Okay. Innovation is the topic. It's topical. And this is a recent economist. Do you recognize, oh, well, it's on both sides. Do you recognize what the seat is? Well, in Canada, 40 years ago, we envied Sir Thomas Crapper the guy that invented that. We wanted our own Sir Thomas Crapper. So, innovation in the cold climate. I was in Ottawa. What I really want to speak to you about, let's see, let me get my note here. Oh, it's over there. So, a couple of things to cover quickly. Tools for policy development, if that would be of interest to you. The parallel between physics and economy and economics. What I say about economics is largely informed by Richard Lipsey, a collaborator of mine back in Vancouver. For those of you who don't know, I want to say something about him. Aside from the fact that he is a fellow of the World Academy, he has 9 honorary doctorates, has over 5 million textbooks in print, is in his 80s, and is as active as ever. And he's a wonderful teacher. And that's the point of mentioning Richard Lipsey, because he's not only a great economist, perhaps Canada's greatest at this point, but he's a great teacher. And I'll have something to say about teaching. So, okay. How do you measure? Is there a question?
I use his textbook.
Oh, you use his textbook. Well, you'll have dinner with him when you come to that.
Thank you.
And you all will. We have kind of an interesting group there, so please. Okay. Wrap it up. OECD. I was hired into Ottawa, the Ministry of State for Science and Technology, at the earliest stage of science policy implementation and development in Canada. A physicist, but I had some experience in industry in the U.S., and what they wanted to do was to increase the pace of science and technology in Canada by developing science policy. Well, fair enough. I was naive and at a senior level, a really great combination. So I looked for, well, I didn't know that you couldn't do this. So I looked for the tools with which to paint the picture, and the tools were available from the Frascati manual. And so what did Frascati tell us? GNP, gross expenditures on research and development as a percentage of GDP, how did Canada rate? And we were only of the OECD countries, we were down at the bottom except for Italy. So, this didn't make sense. But in Canada, it was used as an argument for putting more money into science. In Italy, nobody cared, because the comparison didn't mean anything. So here's the lesson that I learned anyway. Physics here is a chart of some sort, but the error margin is always shown. An economist will take OECD numbers, run it out to 2 or 3 significant figures, and not show the error margin. So little did I know that this was such a macro tool for assessing the pace of science and technology. Furthermore, the whole cultural focus was, let's get into the hard sciences. We can do something there, the soft sciences, not so much. This is where did I put the darn thing?
You don't have on it. Click it.
I don't expect you to read this. I just want to illustrate what it is. This is the full classification of fields of science and technology. So here we have a forum on science and technology. Well, this is science and technology by an international classification that is commonly used. This I took from Australia. It's the same thing with the OECD. The important thing is that here we have natural sciences and engineering, social sciences and humanity. Well, the natural sciences, technologies, and engineering, they're the hard sciences. However, human beings are involved in the social sciences, and we don't know very much about that, and we don't have very good measures of that. And economists have taught us that, well, we use what we've got. Now, I'll mention Dick Lipsey once more. I met him many years ago at a conference, and I said to him, I have this problem with GDP and most expenditures on research and development. He said, oh yeah, they're all suspect. And there are political reasons for that. And economists don't really get their own empirical information, their empirical research. Economist research is refinement or post-analysis of other people's data. So let me just fast forward now 20 years, 15 years that is. I ended up with another career in the tax department delivering incentives for research and development. That gave me a chance in the process to meet the individuals in the companies that were doing research to verify that the work was being done. So I was able to ask their stories. And in Canada, the view of R&D was that white lab coats, PhDs, obscure subjects that have no particular interest. Whereas in industry, technicians, engineers, people with partial degrees, people with no degrees, were trying out new things, doing all sorts of stuff. And there was no reason for them to report to a reporting agency like this was Canada. So we had a new database that we could then examine, and this is what I have to tell you in summary. Research is happening with everybody, everywhere, in every enterprise, or the enterprise is dying. And we've made something elite out of the notion of research and researchers. The people's stories are very interesting. We don't scarcely understand them. We don't know what the provocation is. It starts somebody with an idea and brings it forward, but it happens not in a gross scale. Yes, it's nice to have money. It's nice to have buildings. Even on a micro scale, microeconomic scale, to have clusters of companies. But I'd like to suggest to you that we need to have some nano measurements of what happens with each of us as individuals. When we get an idea, we talk to each other, we make something happen. How do you do that? What tools do we have for assessing the climate in which we can work collaboratively?
Thank you, Roy. That was actually exciting. And back to Reverend Danny.
Thank you very much. It might be a challenge to speak after the predecessors because I would never be so good and entertaining as well, for sure. First of all, thank you very much to the organizer for having me this opportunity. I had prepared a fully fledged presentation, but then the chair told me that I had only 6 minutes, so I decided that I won't as much as possible and to tell you something that you may find interesting and which may make some sense. Yesterday, at the opening of the conference, Mauro Giacca did an overall presentation on the International Center for Genetic Engineering and Biotechnology, which is my institution here in Trieste, and he gave you a glimpse of the various activities among which the key activity is the building of capacity or enhancing capacity, as they say now, of which, of course, education has a major role to play. So we have developed a number of programs, including the PhD program, and Mauro mentioned also this podcasting and iPod iTunes U system, which makes all our seminars are available online and can be downloaded. I will not repeat these kind of things because they don't make much, they might not be very interesting for you. I would like to give you two examples of activities that the ICTP is undertaking or has undertaken in the recent past, just as examples on how we can be also a little bit innovative in way of training and educating young scientists and reaching that integration which was mentioned by the very first speaker. It's at the end of the day what we are all aiming at, especially when we are dealing with developing countries. The first example is a program that is just ending now, that we have developed together with the Academy of Sciences of the Developing World and with UNESCO, the International Basic Science Program of UNESCO. And I'm very glad that the ambassador of Hungary to UNESCO is with us today, because I think it was a very successful program. It was a very successful program because with a very minimal investment, we have been able to develop a number of networks among laboratories within the developing world, putting together countries in which there is a certain degree of proficiency in science with those countries which the Academy for Sciences of the Developing World has defined as scientifically lagging countries. And the whole aim of this program was to enhance the mobility among scientists and to permit those scientists coming from the least developed countries to work in laboratories in a bit more advanced countries. And the numbers are quite impressive. We have networked 12 different countries, and I think in a period of only 2 years there has been something like 35 or 40 students which have been fully trained up to the level of a Master of Sciences. This is the first example which I wanted to give, and I think that both Twas and ourselves can provide you with any additional information to make it wider if you are interested. The second example is a little bit different. Yesterday, Mauro mentioned to you the issue of the genetically modified organisms and the fact that we had a facility that was attacked, etc. Now, obviously, dealing with biotechnology, you cannot avoid dealing with GMOs. But our approach has always been to provide information and education and training in order for the decision makers to take a decision which is based on scientific evidence and not on industrial commercial interests or political blackouts for reasons which go beyond any comprehension. Based on that, we have developed a number of programs of training, of dissemination of information and so on. And 5 years ago, we have been approached by the Bill and Melinda Gates Foundation to implement a major program within Sub-Saharan Africa. That program was aimed at enhancing the capacity of the regulatory systems within Africa to decide or to define their regulations to adopt or not GMOs in agriculture. We had a number of activities, I will not bore you with that, but we were successful enough to get from the Gates Foundation a second phase of this project, which has started just now. It is a $6 million project for a period of 4 years, so it's substantial, in which, among the other things, we have developed a training activity for students to go, in collaboration with the University of Adelaide in Australia, to receive scientific training, but also an opening to the regulatory systems within the world, and in particular within Australia and Canada, which have a very developed experience in dealing with applications for the release of genetically modified organisms. And we have also established connections with their home countries, the home governments, to ensure that after their training, which can last up to 2 years at the University of Adelaide or among the regulatory authorities in Australia and Canada, they can be reintegrated within their own government, within their own regulatory structure. Obviously, we have just started this project, so I cannot say, as I said, about the UNESCO one that it was really successful, because we will know better in a couple of years' time. But I just wanted to share this with you because the classical capacity building activities or the classical educational activities, we have many examples. I think that this is something a little bit more innovative, which has, I insist on it, the aim of integrating capacities, experiences, and possibly cultures within different countries. I hope I was within my time.
That's very exciting, and as some of you know, 6 of the 10 highest growth rate countries in the world now are in Africa. That means that there's an expansion now of absorptive capacity for these kinds of training. Godspeed on that work. That's great. Okay, Ulrika, we would be a pleasure to turn to you now. The mic is coming your way.
Can I be without mic? I think this is a classroom and it sounds like where I teach usually.
Do you need it?
Yeah, I don't want it. Okay. I think I have 2 things that I want to explore here, because the title of this session is actually Recognizing Talents and Genius Education for the 21st Century. And then when I think I first read that sloppily, and then I read the concentrated abstract, and I said, I know how I can contribute. But then I realized at the end that I can contribute in 2 ways. So first I will talk about what I think is important when it comes to recognizing genius. And then I will give an example of somebody I actually have studied from childhood onwards, because I have done a biography of a genius. Okay. So let me first, I will talk about 2 things. The first is about this idea of recognizing genius, and the second one is some details I have from a case study I have made by myself. My point about recognizing talent and genius, in the first place, is I think that one can actually not have to recognize it, but one can try to develop it so that it can then later on maybe be recognized, because it's a developmental process. And this is something that I'm quite interested in. I myself am working at the Illinois Institute of Technology. I am in charge of something called the Camera Scholars Program, which is a program for our elite, the top 1% of our applicants. And these people, these young students who come in, are extremely bright and also already have signs of leadership skills and kind of service orientation and curiosity for research and stuff. We have all kinds of good signs. And my task, partially as a leader there, is to help them develop in various ways by finding venues for them to exercise their leadership and development and so on. And the whole university is helping, so it's a very interesting thing. And one can see these young people develop over 4 years. I also experimented in my classes to see if I can do something that sounds almost impossible, which is if one can create and generate group creativity for a particular purpose. And I think it is much easier than it sounds. It actually can be done, because there is so much inherent enthusiasm in young people, and they just need a few pointers, and then they will take over themselves. You don't have to do very much. All right. So my point is here, my basic point is that I think one should, from the very beginning, do the best to create a climate, as just heard here, and a climate for creativity. A climate in which creativity is possible. I can give you a counter-example, which is a climate where creativity is not very possible. That is a forbidding climate where you are afraid of making mistakes. Now, engineering can be maybe such a field which creates a climate that you are afraid of making mistakes because you have very little time, you have to learn a lot, at least at IIT, and there is not a lot of margin. We have good students, we have good leadership there and so on, but I still don't think we have a climate for making mistakes. And that is something, on the other hand, we just heard, I think yesterday, that it is very important to have these iterated errors, and we heard from Ivo also about the importance of errors. So at least a climate of trust and kind of a friendly climate is very important. And you can see in classes already, because I'm an active teacher, you can see in classes the hesitancy. You have to bring these people out. Sort of work with that. Okay, how can they innovate if they don't even dare to speak? All right. So, my point is that there is a lot to be done at the level of schools and level of colleges, and I think what has to be brought in is our new capabilities of students, and they have to be developed in various ways. And I believe one has to bring in capabilities for future employment, and that is, it is rather requiring, but they can actually certainly do that. It's just that we have to create possibilities for that, and that is for teamwork, that is for intercultural understanding, that is for interpersonal communication, interprofessional understanding. That is quite difficult. But if one puts one's mind to it, one can maybe create programs and activities where this can be developed. So it becomes a kind of second self of sorts, because that is the kind of person that we need out there. And we can give a head start if this becomes part of the educational system, and one gets academic credits for it. It will give these people a head start, because those are the skills that I need today. So that is my point. And I can say that this is relatively successful. At my university, there is a program called Interprofessional Projects that everybody has to take, and we are developing them all the time, because we have realized that. But I think also in other countries and the developing world, I think people need to give a head start, students need a head start with these kinds of skills that we all need because of the networks, team-based, and learning to learn the kind of world we live in today. Okay. The other thing is, I wanted to say about this particular genius that I have studied. This is Bill Hamilton. He is the one who cracked Darwin's big problem about how can altruism, which is a self-sacrificing behavior, or self-sacrificing behavior, how can it ever evolve? It doesn't make evolutionary sense. Well, he solved it this way. It doesn't make evolutionary sense from an individual's point of view because the individual is going to die. But it makes sense if you can save, by this behavior, you can save the other individuals who are related to you and therefore share your genes. Because if you have enough cousins of various sorts and you save them all, you can make a calculation about how much it balances you using your life. And one can actually do that, and that is what he developed mathematically. So here we have, and what I have studied is, this was the first thing he did, and then he did many, many other things because he was a natural pioneer. He went from topic to topic, he opened up a new topic, and then after a while, when he had solved it, he left it to others to continue. So when I looked at what it takes, I think it has to do with how can we identify these features in a very young person. So I went to his childhood. I looked at the teachers who identified him. And I would say it has to do with certain features. Should one take a chance on the youngster who has not yet done anything? How early should one start with this? But some features I have found is extreme curiosity, independence, somebody who pursues something by himself or herself, totally disinteresting other people, pursuing something for its own sake. Lots of imagination, but also a kind of, that is something that he later developed, a kind of filtering out the bad ideas. And a great interest in puzzle solving and problem solving for its own sake. So you are like, so to say, all the time problem oriented. You are looking for problems. This Hamilton was also looking for patterns everywhere. So he was at some kind of general interest, universal level. And this is something that I read in Evo's and Gary's paper also about creativity. I recognize some of the speeches, but I try to add something to it. But the other thing is, he also had, and this is important, most people think that he was somehow isolated in the universe. No, he had actually a supportive family that both were supportive and let him take risks and do things by himself. So there are many background factors that can support this. He also was exposed early on both to art and to sciences, both to engineering and to nature. His mother was a naturalist, avid naturalist, who knew something about gardenism. His father was an engineer inventor. So you had these kinds of tensions and so on. And I believe when we talk about networks, what happened in his very big head was the development of lots and lots of connections and neural networks. And also cross kind of cuttings that usually don't happen. So later on he had this imagination that went everywhere. But he could also discipline himself with the help of math and say, no, that is nonsense. Okay. Out of his 100 ideas, 10 were good. And he found them. Okay, I will stop here.
Thank you, Ulrike. I wish you had been my teacher. Many of the qualities that you discuss, I see in the social entrepreneurs of the world, and they are a source of creativity for the public good, which I wish somehow our academy could somehow interact with them. Ashoka is a group that's parallel to MacArthur Genius Awards by giving awards to social entrepreneurs kind of scale up their work and have more impact. And they have networked themselves very creatively now, so that big public policy issues go to a network of, let's say, 300 to 2,000 in that whole organization that would work on issues. It'd be very interesting to figure out some synergies. So, now Dr. Zadancic, who is from our neighboring countries.
Thank you. So, first of all, I would like to apologize to our good friend Vito Turk, who unfortunately had an inconvenient appearance at court due to some official matter, and he had to apologize for and asked me to extend his best wishes and regards to all of you. So, in this talk, I would like to focus on fundamentals of education, how to identify and stimulate development of talent, and also the role of technology and its rapid growth in the past few decades and hopefully also in the next few decades. So, here I come from Jonas Stefan Institute, and there we always had good fortune to be surrounded by lots of clever, smart, and well-educated individuals. So in my formal education, I actually had 5 members from the World Academy who were the teachers, and one of them was also my supervisor, primary teacher, and much more, Professor Zins, who passed away last year. And that was actually the relationship of 24 years, which made a lasting impression. And I think this is actually the fundamental, where you have the teacher and the student that can interact one-on-one for over an extended period of time, and that's basically how the education is transferred from the one who knows to the one who doesn't know. So people are thinking about tacit knowledge, one that cannot be really written down in the book, but we know education, I think Einstein not highly approximated definition, that education is what remains when we forget everything that we learned in school. So this is actually the education that I would like to talk about. And here about this education, why do we have one teacher and a lot of students at university? Wouldn't it be better if we had one teacher and one student, they interact all the time? We would learn faster. So it's actually a spending issue, or a spending cut, or how we call it, financial issue, financial constraints. There is not enough money to have one teacher for every student. So you need one teacher per, 10, 20, 50 students, depends on the university or the classroom. So the issue is, how could you get to that situation when you have one teacher, one student interaction? Is it possible that new technologies, we know about Moore law for like 4 decades, it's just going up. I mean, the speed of computers is going up, the size is going down, the price unit of performance is going down, and it's a logarithmic scale for the past 4 decades. I mean, long time ago people said it has to stop, it's beyond the laws of physics. Now they say it has to stop in like 8-10 years, because then the size of the microprocessor will be like the size of the atoms. No more room for progress. But still, I mean, throughout the history, it is just going up and up. So there are some futurologists like Ray Kurzweil, I think is very famous. He extended this back to the 1900s or even back to almost the Stone Age, and it's going up and it's accelerating. So what happens if this progress accelerates? I mean, my phone is like 2 years old and it's almost ancient compared to this new phone that almost every year something happens. If you look 40 years back, no phones, no personal computers, no internet, which means what will happen, nobody can predict what will happen. But we know that something will happen. And the question is, of course, how will the humans adapt to that? There are many scenarios. I mean, in science fiction you can see all sorts, from the idea scenarios back to those like the Terminator or even something worse. But nobody knows what will happen. The issue is, can the humans adapt to that? So that is basically the growing demand on knowledge on human persons. How do we follow up with this computer that's getting smarter? I mean, every year my computer is getting smarter. So how do I follow up with my computer, with my telephone? That is basically the issue, and I think von Neumann was actually one of the first serious scientists who was talking about the issue of technological singularity. For him, that was the point where the technology is so complex that humans have a hard time following it. And then, of course, other people kind of extended this, and they said if this Moore's law continues for 10, 20, 30, some people say 50 years, the computers get smarter than the humans. So what will be the role of the humans? Will they need the humans anymore? And if they are that smart, then they would learn ever faster, and this ever faster learning would actually cause them to solve most of the problems we know today. So on the good side, it is most of the environmental problems could be solved with such computer simulation. Computers are so smart they could solve them like in no time. This is the most difficult problems we have in environment, in society, in other fields of. However, then the issue is why would these computers need humans? And perhaps the only sustainable solution is that the humans and these computers merge together, and we kind of use this as part of the extended identity of human beings, as we heard in the talk this morning. So, where do we get these students? We established this graduate school at our institute almost 10 years ago, and the biggest issue is how do you get the students, and another big issue is how do you get financing. So for the students, one way is, of course, to migrate between the countries, and that is a bad effect because of the brain drain. It threatens the human capital in the donor countries. But it also is an opportunity for those young people who go to other country and for accept this country to improve their human capital. So there is actually a recent paper by Kanch and Kivita who found that it is actually possible to also improve the human capital in the donor country if they accept attractive return migration policies. And even if they don't have good policies now, they can still accept good policies. Okay, I know this is difficult. We still don't have a way to convince like our leaders to accept good policies, but when they test all other possibilities, perhaps they accept some good policy. You never know. So anyway, a good way is actually to increase national innovative capital in short time. If you increase investment in R&D and education, and you can get them educated people from other countries back to the country, that is what Kreischer has found. I would also like to say a few words about human welfare and educational effects of it. We all know that people who are educated are usually more rich, but it's not a good example because Bill Gates is among top 3 and he never finished the university degree. So I would like to talk here on happiness and on life expectancy. So regarding happiness, there is actually a study of Wiener and Seligman that for happiness you only need good social relations, everything else is expendable. And if we take data from all databases of happiness and we make a correlation for these education, so these are people who are not educated, primary education, secondary education, some level of university education or university education, and this is the life satisfaction that's given in the questionnaire. So you see people who are more educated are actually happier by their own answer. But this is subjective, so let's go to another more objective. So this is actually life expectancy versus education. So this was a study 5 years ago in Eurostat. This is the difference between life expectancy for people who have a university degree and those people with primary degree. You see, for instance, Estonia is the biggest figure, almost 20 years of bigger life expectancy. So people with a primary degree cannot even reach the year of 60. With those with university degrees coming to almost 80. Which means you spend 8 years in education and you add 20 years to your life. I mean, Estonia is an extreme example. You see that Finland or Sweden or developed countries, there you can only get like half a year of life expectancy if you spend 1 year in education. And of course for men it's more than for women, because women already have high life expectancy and don't need that much improvement from education. So these examples are actually the ones that I think are useful for attracting the best and brightest students to education systems. If they study, then they will live longer. Okay, so in conclusion, I would like to say that what we need is actually a good combination of teachers, students, and technology. What will happen to technology, nobody knows. I mean, in 10 years, if somebody wants to predict what will happen in 10 years, then better not, because it will be completely different. But it's important that we use that technology. We have a good teacher, a good student, they work together, and they use everything that is there. That is available. About brain drain, this is actually a problem because of bad governance, which means that sooner or later, I mean, politicians will learn to accept good solutions because they will test everything else and it won't work. Or technology will be so advanced that they won't even have the possibility to use the best solutions. That's another possibility. We never know. We will see that. Like 10 years maybe. And what we can say is that educated people are also happier, they live longer. So this is a possible motivation for best and brightest to kind of join this education process, and who could actually not join the education when they will also be happier and live longer.
All right, I'm going to change the ground rules just a moment here, because in a moment I'm going to invite our distinguished fellow Emil to give his remarks. But I wanted to just put on notice 2 people that I'm going to call on to give, if they would like to, some comments about how academies are best interacting with the fostering of science and technology, genius training. Where's some of the most interesting contributions, just kind of to stimulate us. So, Mohammed and Yuri, if you are kind enough to say and give a comment or 2 on that, that is great. And now it's my great pleasure to invite you to address us.
Thank you. My position as a reporter, I would firstly to thank both for your work before the conference, because he was an excellent example for networking us before physically face-to-face meeting here. And secondly, I want to comment the brilliant contribution of Ipos Laus and Gary Jacobs and recognizes unrecognized genius. Ivo and Gary joined their forces to show us the path to recognizing unrecognized genius. I agree all of the criteria in identifying the excellence of personality in vertical field. The capacity to transcend the limits of conventional thinking, to unify disparate phenomena, to understand the whole greater than the sum of its components, the personalities able to perceive a deeper level of causality than the current conventional thinking, and to see opportunities where the canonic thinking sees nothing but risk. Women and men endow with the capacity to see life in its profundity and totality. I am totally in agreement with the idea of a distinction, both moral and material, bestowed upon creative minds and personality not yet recognized in their true dimension. But let's keep as a secret the word genius, at least for a while. You can never tell the end of the story, at least when you do not work for Delphi, Oracle, or Hollywood. Herodotus tells us that once upon a time the richest king of earth, Croesus, asked his wise Athenian poet and statesman Solon, who is the happiest man alive, expecting to be designated himself as such. Instead, Solon disappointed him bitterly by quoting the name of two young peasants who died in sleep, and by teaching him that until the end you cannot be sure about anything. Let's not be disappointing in our effort to encourage the young and brilliant personalities in our time. In the proposal exposed by Ivo and Gary is looking mostly toward the young. Professor Dobrovolsky's contribution to our debate that is regard to the old. Biologists and psychologists alike have concluded that singers maybe not react as quickly as their younger contemporaries, but that their reactions are the result of a more complex process of thinking, using comparatively more networks of their brain and a more reflexive mind. The old and wise are not doing competition with the young, and both that have to complete each other. The lifelong learning is a way of making the tool of progress outer longevity, which much too often is perceived only as a burden for society and as an obstacle to the advancement of the younger generation. Again, I have to agree most willingly to the main thesis of Professor Dobrovolsky. Lifelong education is essential for the better quality of life, both for the individual and for the society. As he so aptly writes, it is necessary to provide intergeneration integration based on lifelong learning. Both the intervention of Morley Lipset and Alexander Zitansek met me my utmost appreciation, and they offer a rich matter for reflection about education today and the near future. Both questions which reasons the current paradigm of the formative process, striving for a new model of learning, a process which must be understood in the widest of its signification. Defining the current paradigm answers, and certainly in contrast to the new one dominated by questions and wonder. Let's remember Pascal in Entretien, who praised Montaigne for disabusing those who cling to their opinions and who believe that they have found unshakable truths in the sciences. Morley said, McElvany asked for a way to rehumanize education, while Alexander Zidan-Zeger began to draw our attention to the new rhythms of acquisition of transfer of knowledge in our time, asking for an early warning system, so to say, mean to identify and put to good use as soon as possible the individual with a creative capacity. Both interventions reach in fact a problem which bothers me a lot. How do we support the democratization of the education at all levels without provoking at the same time its massification? During my long years as a professor, I had to struggle on a day-to-day basis with this problem. We've become dramatic in the last decade in our university. My experience abroad tells me, on the other hand, that the situation is not radically different in the Western university, in spite of the fact they had not suffered as the Romanian or other former communist country from the unconsidered intervention of the communist dictatorship in the life of the academic community. I am aware, on one hand, that we have inherited an educational structure imaginated more than 2 centuries ago. The structure was intended ultimately to form a minority of 5-10 young men, only when, of course, as to become the educated rulers of their own not-so-educated generation. Today we ask the same structure to manage the future of some 85-90% of our youth. In the 19th century, the industry needed workers to generalize primary education, no more, but not less. Nowadays, the new economy needs workers with high school and college, which means at least 3 years of undergraduate university studies. Does that mean also that they should resume to be a poor copy of their elders, with a shallow and superficial access to the fundamental superior knowledge? Does that mean that if they are computer literate, that may well be ignorant in a traditional sense, not reading literature, not understanding either mathematics or philosophy, unable to write without a computer corrector, indifferent to beauty? Does it mean that may wave away the civic rights and duties, mostly out of ignorance, that of indifference? I have no magic wand to solve this range of problems, even if I think they are crucial for our time. I think, however, that we must start by changing our canons, by inventing new paradigms. To put it bluntly, we must stop mending the traditional school and start inventing a new and different one. Questioning is all right. Imagining may even better. But we must rethink also the basics. At the beginning, split our crowded classes in classical groups, able to identify and develop each child's gift, and to offer each of the students the joy of discovery and of achievement. At the midway, alternate in undergraduate courses the magisterial lectures for all and the functional growth of the student interested in solving a defining problem. It's a bit offering to the most gifted all the opportunities they need to blossom in their own and to exchange ideas in a variety of related areas, libraries, scholarship, internship, jobs. I am painfully aware that this new paradigm may seem rather utopian, more adapted to the how society is so highly praised by Gutenberg or to Rabelasian Abbé to Telem than to our plea. And so, in subsequent answer to the global crisis, education costs. Did anyone ever measure how much may cost the lack of education? I can say for sure that, for instance, the number of lives lost to the early abandoning school, the juvenile delinquency, or just to moral frustration, costs to the entire society a huge amount of money, let alone of human achievement. And I strongly believe that if we leave the current trend of massification to invade the whole world of our school and university, we shall lose forever all the benefits the democratization of the educational processes offered humanity in the last 2 centuries. Let me confess, on the other hand, that it was very glad to learn from our learning colleagues that education is positively correlated with happiness and life expectancy. It was my inner conviction anyway, but it was a joy to be right with such distinctive minds. Thank you for this. But sorry, last but not least, the report of assisting developing countries to develop their own scientific and industrial capability due to this pandemic seems to be exact antidote to the massification. I worry about the International Center for Genetic Engineering and Biotechnology is doing, in my view, exactly what should be done in all fields of science, as well as in humanity. It provides a developing the world with a sense of excellence, of research, and etc.
Thank you very much. You've given very nice encouragement to our panelists, and indeed they are to be thanked for their contributions. Now, Mohammed.
Well, thank you very much. It's really a very interesting set of presentations. You wanted to know what academies of science can do in this topic of searching for talent and recognizing talent. And of course, the academies of science are merit-based academies. The very fact that they have members, meaning that they elect members on the basis of merit, this is a recognition of accomplishment. But unfortunately, in almost all academies, we have an aging community of members. In IAP, we made a calculation the other day, we have 106 members, and the average age is about 65. So these are, of course, well-established scientists, very well recognized by their peers. Sometimes, of course, an academic can get it wrong. The French Academy, for example, never recognized Madame Curie, and it has a member, 2 times Nobel Prize winner. But these are odd cases. I think the basic problem is how to link up with the young income and what's talented scientists in a country or university. And this is where most of the academies have been failed or have failed so far. But I can tell you that the situation is now changing, and changing very rapidly. Many of these academies are now starting to link up with young scientists. So there is now this notion of what we call the young academy, which is inspired by some of those senior academies. And the young academy recognizes the most talented young scientists below the age of 40. So these are elected on the basis of their accomplishments, but they have to be below 40. And the interesting thing about this is that the membership is not for life. They become members for 5 years. After 5 years, they graduate and a new class comes in. So all the time, the academy of members is below the age of 45. So this actually started not long ago by the German Academy, Leopoldina, and also by the Dutch Academy. But now it is really maturing in many places. In Africa now we have about 6 or 7 young academies structured in the same way. So this is one way of getting recognition of the young generation, and it's very important. But I really want to make a quick comment about IAP, what it does in the area of science education. And a very basic question that was asked by many of you is how we can train a new generation of not only just talented scientists and scholars, but those who can solve real-life problems. And this is very important because of the challenges that we are facing at the moment. And IAP, quite recently, has started to look into the way that our children are educated, starting from kindergarten all the way to university. And there is now a new way of teaching German, which has been introduced by IAP. It's called inquiry-based science education. In France, they call it a MALAPAC, hands-on education, or education by doing, educating by doing, to enable the students and the children to learn the method of education themselves, without them being told that 1 + 1 = 2. They have to discover the facts themselves. And fortunately, this is now developing very fast. Maybe it started in the United States and in Chile, but it's now spreading in all regions of the world. This is inquiry-based science education. And I think it will have a very positive effect in making children know how to address problems themselves and how to be able to solve them. They learn mistakes. And this is the art of learning. They make several mistakes in a particular experiment, but finally when they get the result, then the result is fixed in their mind forever. So they are not just told about what to do, but they discover the truth. And this is a very good example of doing it. Another way, which I find myself extremely important, is if you look at the university education, for example, the way we were educated. I'm a mathematician. When I entered the School of Mathematics, I didn't know much about other areas. A little bit of physics, maybe, a little bit of chemistry, but nothing about the social problems. And I think there is now a new way of introducing topics in university, the so-called integrated basic courses. Any person, any student entering the university has to take a compulsory integrated course. A bit of science, a bit of social sciences, a bit of law, a bit of economics, but basic information about all areas of knowledge. And I think this is so important for people who want to address how to develop a new generation and solve real life. So in my view, this is also extremely important. Okay. And I think I have a final point, and that is in many of our developing countries, the education system is very, very low in quality. And in many cases, some of the most talented students, they just get lost. And one country that recognized this fact is South Korea. In the early 60s, they introduced so-called elite schools, or schools for the most talented and gifted students. And that was a kind of a fast track of educating the best and the most talented students. And they went ahead with that. And then after they graduated from the school, they went to a university that can only accept the most gifted and the most talented. And this type of fast education, I think, is very much needed in many of our developing countries. Unfortunately, it is not. Most of the talented we have in Africa, for example, they get lost because they go better at education. Thank you.
Thank you. Yuri?
Yeah. Thank you very much. Well, I shall continue exactly what Mohammed has said about science education. And this is really, well, if we speak about the lifelong education, it should start very early. That's right. And actually, European Academies, ALEA, has created a working group of, when was it? 4 years ago, actually, for the science education. We had one conference, and now there is also a report released last December, so it is pretty new. It's a review of science education in Europe, views and actions of national academies. So that now it is together with IIP, and this is something what I recommend you when we get it from the web, so alea.org. And there are several very good examples well, France was mentioned, but it's also in Sweden, also in the UK, Germany, some other countries. And it's really something what is doing one for the primary education and for the secondary education already, so that the students who will come to the universities are already prepared for such kind of thinking about the creativity. And there are actually 2 points. Well, I'm not going to refer to all this views and actions, but there are actually 2 points in it. The first is the science education, in the primary school, is inquiry-based. Just to introduce this inquiry-based thing, and the slogan is actually very simple: to curiosity. So that's quite clear. But this is one side only. And there is another very important point in it. We have also to train the teachers who will be able to carry on such kind of inquiry-based education. And I think that the academies, as far as now the European academies are there, together with now the IAP, so that the world academies, there is something going on. Mohammed could give some more examples what will be in the future. But this is something that the academies can do together, despite that they are mostly not very young people in the academies, but thinking about the primary education and the secondary education. Thank you.
All right. Now, we're going to take 2 fast comments. I'm sorry if we had 2 already, but Alberto, I had your hand.
Yeah, I don't need the mic. I think I agree with everything I've heard, and I think, though, our academy can do some contribution. As Amy was saying, to calculate the cost of not giving education, but I would say also the cost of giving the wrong, obsolete education. Like I tried to show in my presentation, I think we need not only the history of education, but also sociology of education, sociology of knowledge. And the point that were the 2 previous input from the public, I think is important. For example, my institute in Italy has been doing training 50,000 teachers with this program we have about teacher effectiveness training. Often teachers are really toxic to the younger minds. And so the point is to have a virtuous process to learn how to learn. And we could do a research, like in my field, which is the field of health. I have launched an international research where we do not only the effective, how a doctor is effectively erogating service as doctor, but how we train effectively doctors, psychologists, and this can be easily done. We already have a template, a STAR template, which each profession uses the same instrument. They are already available for free in English, in Italian, in Spanish, in French, and maybe UNESCO could help us, because our academy, for this, could even have a grant proposal and time up with sister organization, and would be a significant contribution for a better world. Without better education, we're not going very far.
I'm going to give a short comment. Just that one of the things that the opportunities to solve problems has been kind of a theme here. And another chapter in my book of things that didn't go particularly well was my trying to get the Secretary General's office at the UN to agree to open source competitions to help solve public policy issues. Now, the nice thing about this is that it draws on talents at all ages. There's no hard kind of business on this. Young people can contribute. They've been very successful. It crosses internationally very easily. And the nice thing for the UN, particularly, is that it creates a constituency for solving a big issue. And I'm talking about, problems that are circulated to 100 or 200,000 science and technology or social entrepreneurship, big lists of people to get them interested in problems. And then, when they're done very well, you take maybe the 4 or 5 top ideas and go back to your list of 100 or 200,000 people and say, which one do you think will work well? It's good public policy choice strategy, and very inexpensive. And it's things like this that use the internet networking in ways that can be really helpful to educate and to solve issues that I think are going to be important. Because we are the Academy of Art and Science, we are going to close this session with art. And here is a poem.
There will be nothing for you to. There will be nothing for you to watch over here. This is for my benefit, so I can read what somebody said. Earlier last year, one of our rather illustrious, well, fellows are illustrious, whether we like it or not. A very well-known, respected fellow in Vancouver had an honorary doctorate conferred by Simon Fraser University for his contributions in advanced in continuing studies, continuing education. He previously received an honorary doctorate from Emily Carr University of Art and Design. He's a rabbi. He has 2 PhDs in comparative religion and art history, and he's a very remarkable human being, and I hope he has the opportunity sometime in the not-too-distant future to meet all of you. So please close your eyes. Don't try to read ahead. Also, Dr. Wasp, Professor Wasp, Rabbi Wasp, is very wealthy and a philanthropist. And he takes care of libraries, and he started all sorts of things. So here, imagine here's the podium, and there are 5,000 graduating students. And he's just received his, his hood, and he proceeds with his talk. And I've abbreviated it somewhat. So this is what he says. Today I advocate that you all become beggars, thieves, fools, arrogant, and masters of destruction. I realize these may be rather shocking offerings, but here they are. Beggars. They're not just the poor and downtrodden, but also holy beggars. This is what I've learned from beggars, that we are each other in disguise. I've learned how to ask and how to receive, how to beg for knowledge, love, and light. Because there are so many things that we cannot accomplish alone. So it's these humble ones that I refer to, and I wish we could all become like them, like those beggars, and share a meal at the beggars' banquet to come. These, I trust that this graduating class, and therefore all of us as colleagues, will be the most honest and ethical, and yet to truly succeed in your studies, you must also learn from thieves, who are always looking to profit from what is not theirs. This applies, of course, only to learning. Fools. I wish they'd become not only domesticated and highly trained scholars, with these 5,000 bewildered students or graduates, but that you also embrace the crazy wisdom of those who live life large, those who are intoxicated with ideas and eager to see them realized. To accomplish this, you sometimes need to play the fool, to stand on your head, to see things upside down and sideways, inside out, and from a distance. All these points of view. If you are fortunate, you may slip into a state of mystical union, where the knower, the knowledge, and the known are one. I'm going to go with the last one, Masters of Destruction. This last